Good afternoon, everyone. So, in the previous class, I have discussed about program evaluation and review technique, that is PERT. So, you know, PERT is actually your event-based network type, where if you have to use any evaluation of any program of any project that is uncertain and probabilistic, which has more uncertainties, then we can use this technique, that is PERT. So, unlike your CPM, it is mostly your event based, where the CPM is your activity based. Okay, and as you know, the events are denoted by the nodes. Okay, suppose this is the I event, this is the J event. Okay, and the activity are denoted by some work that is done. Okay, event will give you the amount of duration which either some work is preceded, some work has started, or will be completed. Okay, so this I is your successor event and J is the predecessor event, and the arrow represents the activity and how much time it is consuming. Okay, so in the since this approach is more probabilistic, so we can have a frequency distribution. So in a frequency distribution which is probabilistic, the area under the curve which we consider will give me the and the ratio of the percentage, the partial ratio of the area that is covered divided by the total area will give me the probability of how much the frequency of the occurrence or the probability of the chance of completion of a project is fulfilled. So, activity is clear. Now, if I draw the frequency distribution, so frequency distribution, your ordinate will be having number of activities that is occurring. Okay, number of jobs, number of projects that is occurring. And here will be your time division, the x-axis. That is the now if you see the frequency distribution of occurring of completion of time, most probable completion of time, the number of activities most likely which will get finished early. Okay, this is the mark here. Okay, we can say this type of event, this type of activity which finishes early as your optimistic. Okay, the time which is taken is called your optimistic time. We are taking the least time. Okay, so here it can be noted as your T0. Okay, and if any activity takes the maximum time which is allotted for it, that is called your pessimistic time. Okay, the maximum time which it can take. Suppose now it is denoted as TP, and there will be a mean time between which most of the activity will get finished. So if you draw a frequency curve, it will be more or less like this, where the apex can lie at the center, or it may lie skewed. It could be skewed to the left, or it could be skewed to the right. Okay, so the area under this curve will be a probability function. So for a function of time f(x) that the activity is happening, the shaded portion, the area is given in the probability, the chance of completion of this activity, and the probability is the area of this shaded portion divided by the whole area of the curve, under the curve will give you the probability. So this is the concept of your optimistic time, which finishes most early, or the pessimistic time, which takes longer time, and somewhere in between the most probable time where the activity has the high chance to get finished would be your most likely time. Okay, this is how the time estimates can be divided into these three segments. Okay, so the chances, so here if this activity takes 5 days and the same activity may get completed taking all the uncertainties in 5 to 15 days, and in most ideal condition there will be chance that the activity could be completed in 7 days, okay, or 10 days. So if the probability of getting completed in more far position in 12, then it will be skewed to your left. Okay, this will be more pessimistic, and otherwise for your more optimistic, the maximum distribution will be apex near the optimistic time. Okay. So it is the optimistic time is denoted by the O, and it is the this we would take the least time that we complete in normal conditions. Okay. Pessimistic time, if something goes wrong and the project takes more time, but not considering the catastrophes. Okay, catastrophes, but some unusual thing which happens like any breakdown. Okay, taking considering of that, the maximum time it will take complete is your pessimistic time, and most of the time is the maximum optimum time which will to take considering all the possibilities, which is the maximum chance to happen. That is why the frequency distribution is maximum highest number in your most likely time. That is denoted by TL, or sometimes it is also denoted by TL. So if you have to draw the mean and deviation, you already know what is the mean. It is the total number of activities that is offered divided by the time duration. Take number of activities. Okay. The deviation is the from the total mean time to the difference in time. Is the deviation, standard deviation. So, if you see the deviation, the frequency curve, we can define the deviation, the area, in 3 parts. Okay, in one part we will divide the most time which will occur. Okay, this is the distribution curve. So, for our maximum occurrence of any activity to happen, we will choose this probabilistic curve in the form of this distribution curve. Where this program P here shows the optimistic time, the least time to stay. TP in the this R curve, it is showing the most maximum time, and here it is showing the most likely time to happen. Now in normal distribution curve, if we take the mean as mu and the difference in the time duration in the form of standard deviation, then we can write this the mean as taking considering mean as mu. here on the left will be less than the one part, that is mu minus sigma, and when we go beyond it will be mu minus 2 sigma, and on the farther corner it will be mu minus 3 sigma. Okay, so if you find the shredded portion where the maximum frequency of occurring mu minus sigma is your 68%. Okay, there is 68% chance of occurring in an event. If you consider the deviation mu minus 2 sigma in the range of mu minus 2 sigma and in the range of mu plus sigma, mu plus sigma, then from mu minus 2 sigma to mu plus 2 sigma will be having a probability of 95%. Mu minus sigma, so mu plus sigma we have a probability of 68%. 68% of the total curve area. Mu minus 2 sigma, mu plus 2 sigma will have the chance probability of having curve of 95%, and mu minus 3 sigma to mu plus 3 sigma will have a chance of 99.7%. 99% of 7% of the total area will be covered, which is equal to almost equals to 1. Okay, let's say the solution equal to 1. Okay. Now to perform the subtract the value of TP is your mu plus 3 sigma and the optimistic time is mu minus 3 sigma. So you subtract the probabilistic time with the optimistic time. See, so mu minus mu will get subtracted, so it becomes 3 plus 3, 6 sigma. So the standard deviation sigma will be dp minus do by 6. Okay, so this is how the standard deviation we can get from the optimistic time and as well as the pessimistic time without getting the most likely time, with the presence of having a range of most optimistic time where the activity could finish most early with most likely condition, and the worst condition which will take the maximum time to complete. The average we get the standard deviation. Okay, and variance is what? And variance is the square of the standard deviation. Okay, all of you got this point? Variance sigma is equal to P minus P naught by 6. Okay. And standard deviation is your square root of the variance, square of this. Okay. Now, as I have discussed, that the activity in normal case it may not be symmetric to the center. Sometimes the time which it takes to be early, the most likely time. So it is said it is left skew. Okay, more asymmetric and estimated. And when the time is taken estimated is more closer, the most likely time is most closer to the most pessimistic time, then it is skewed to the right, so it is more pessimistic estimator. So in the PERT evaluation, you will find that most of the curve that we have are not normal distribution curve, but we are using beta distribution curve. Okay, so this is important point, that the curve which best fit for the PERT is your beta distribution curve. If we consider a particular activity that is occurring, because most likely it will happen that either it is optimistic, it is skewed to the left or skewed to the right. Okay, so it is, you can also write beta distribution. It is skewed to the left or skewed to the right, and it is not symmetric to the axis, and it is best suits the PERT analysis that we perform. Okay. But if you see the overall aspect of the frequency distribution, okay, the overall project, then you will find that it is taking the normal distribution. If you consider the overall project, you will find that it is more or less the normal distribution, where it is more or less symmetric at the center. Okay, but if you find activity based, in every activity if you go to find, then for PERT analysis you will find that beta distribution which is skewed to right or left is best suited for your PERT. Okay. So if it is left skewed, it is called optimistic estimator. If it is right skewed, it is called pessimistic estimator. Okay. So this I have given standard deviation dB minus T0 by 6 and variance dB minus T0 by 6 whole square. Okay, all of you understood this information now. Okay, so this, using this we can get the estimation of how well a particular activity is more accurately it is happening. The calculation is more accurate, where the measure of uncertainty, the variability in any prediction is more accurate. Okay, so the uncertainty between the variance will give you, the greater the variance, the greater will be the uncertainty. Greater the variance means if the difference between the minimum time that is taken, maximum time is more, then you can say that it is not precise. Okay, range is more, so that is why it is more uncertain. And the less value of the variance you will find, you will get that my precision level is more. Okay, the least time and maximum time is, if it is closer, then you can say the precision is more, so the uncertainty is less. This is the logic behind the this value of the variance. Okay, all of you have understood? Now the very important point, that is most expected time that we use. So what happens? We have come to PERT using the probability distribution function, okay, normal distribution and beta distribution. Now what happens for our practical use? We have normalized our calculation for our ease of doing any probability, any estimation, using a numerical method instead of going for the curve, which may not be appropriate for a particular application. Because for any activity that is happening, for any work, precisely, the distribution curve may not be accurate for everyone. Okay, we may not found the accuracy in the, if you calculate, you have to calculate using a distribution curve. That is why we are using the numerical value and by giving the weightage factor to the algebraic equation, and that equation is called the most expected time. Okay, so we have given weightage 1 to your most optimistic time and pessimistic time, and 4 weightage is given to most likely time. Okay, so optimistic time is the least time, suppose 3 days, most specific time is the suppose maximum days suppose 15 days, most maximum time is suppose 7 to 8 days. Okay, so like this way for any activity, if you sorted these three values, you can get the most expected time by using this numerical value. Okay, so I will write it down. It is very important because for most of the activity when you are going to calculate, this equation is has to be used. Okay. Let us see one example using which we will understand that how to use the concept of variance and how to use the formula the most expected time to calculate any critical path. Okay. Suppose there is a example which asks to find the particular activity of a project time estimator. This is from two engineers. Okay, these are the two engineers where X and Y have given three time estimates according to them, and we have to find that which one is more certain. Okay, so by the formula of variance and standard deviation, you can easily find out. Try it out. Here, what is given in this example? Optimistic time is given for engineer X 0 most likely time and pessimistic time in days. Suppose these are in days. So 4 days, most likely time 6 days, and pessimistic time 8 days. And engineer Y is taking 3 days least for the activity, 5 most likely, and 8 more pessimistic. So you can say that more or less the maximum time which it takes, the more pessimistic time is around 8 days. Engineer Y is taking lesser time for 3, okay, and most likely time is taking 5. Now using the principle, now using the formula of concept of variance and standard deviation, can you find out which one will be more certain? Which engineer you can say that it is more certain? Standard deviation is what? PP minus naught by 6. निकालो दोनों इंजीनियर का. Then do the standard deviation. See the value how much it is coming. Calculator, all of you have to bring calculator. Calculator लाओगे क्लास में, then only you can practice for your exams. Mobile में it is not suitable because in the exam you are not using mobile. So how will you be habituated if you are not bringing to the class? Write out very simple, just simple arithmetic is there. 0.6 का standard deviation. And what is the variance? Here the use of most likely time is, it is of no purpose. Our approximate time and pessimistic time will give you the assurance that which is more certain. Simple. Which one? Which engineer is more certain, X or Y? Yes, sir. What is the value is coming? The value will be a state. Variance value for last state. XL alright. For X is coming. Is it coming 0.4? For X is it coming 0.435? What is the variance for y? Is it coming 0.69? Okay, 0.69 is around 69, 0.69. So which is more? Whose uncertainty is more? X or y? Y's uncertainty is more because the variance of y is more. 0.69. Here the uncertainty is 0.4. So we can say that X is more certain to get the projector. It's more certain about the time, but Y is more. It is more uncertain. It is taking more time. Okay. Y is more uncertain about the project because the time limit is more. Simple. Okay. Simple arithmetic. Understood the concept? By using variance, we can say that which project is more certain and which project is more uncertain. Particularly. Okay? पाँच पर तीनों होते हैं. Suppose you will be asked definition of what is definition of slack or what is standard deviation or what is mean distribution curve. Then suppose 3 marks question. Simple. Very simple. If you know, it is very simple. If you don't know, you will not be able to do. बस दो स्टेप का क्वेश्चन है. Because variance निकालना है. Variance निकालो. ज़्यादा variance more uncertain. Less variance more certain. Okay. Let us move to another question. So here you will be asked to find out the most critical path. Okay, see this project here. We went from starting from 1, 2, 3, 4, 5, 6, 7, 8. Starting from 1, finishing the event is finishing at 8. And the 3 time estimators are given in this way. The arrow will depict most optimistic time, most likely time, and most pessimistic time. Okay, 6, 8, 11. For activity from event T2, 1 to 3. The activity is 3, 7, 9. The most of PO is 3, TL is 7, TP is 9. So like this way, see, you can find out, you can prepare a table where you will state the first you can give a path. Okay. Next you can give a table where you will say the for this activity 1, 2, 3. The 3 using the 3 time estimators, you can find out the most expected time, right? So find out for each activity the most expected time, right? What are the different paths that a project can be completed? How many paths do you see? कितना पाथ मोटामोटी तुम देख पा रहे हो एक से पहला प्रोजेक्ट कंप्लीट हो जाता है. एक तो ये पाथ है स्ट्रेट 1, 3, 6, 8. Another path is 1, 2, 7, 8. 1, 2, 6, 8. Another path is 1, 4, 5, 6, 8. Okay, at least these 4 paths you can see. So you can either create the number of paths, okay, or later on you can do first you can create a table consisting of activity. Okay, activity 1 to 2, 1 to 3. These are what? 1, 3, 6 are what? Anna, what are this? 1, 3, 6, 8. What are this? These numerics are what? Right. Event. 1, 3, 6. These are nodes which depicts event. And what are this? This arrow shows activity. This is the direction. So which one is predecessor activity? Which one is successor activity? Which one is predecessor? Which one is successor? Which one is predecessor? 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 Successor. 6 6 is predecessor of 8. 8 is successor of 6. Okay. 1 2 1 3 then 2 7 2 6 6 to 8 7 to 8 and so on. 1 to 4, 4 to 5, 5 to 6. For every activity, you will get what three time estimators: optimistic time, most likely time, and most probable time. Using this, what you will get? You will get the most expected time. What is the formula for most expected time? TO
4TL
plus
plus
4TL
plus TP by 6.
TP by 6. Using this formula, just find out for each activity what is the expected time. Simple. 1 to 4 was इतने जगह 6 by 5 6 to 5 was 6 to 5 क्या है? How 6 to 5? It is working from 5 to 6, not 6 to 5. The arrow, see, arrow is important. My direction is 5 to 6, not 6 to 5. ये कॉन्सेप्ट पहले समझ लो, then we will go to most expected time, and there are two next time estimators. Okay, most likely time to finish any work. Okay, the maximum time which any project takes. Okay, and another is the least time which it takes. Okay, there is another concept that I will discuss. First, grab this concept. What's the capital of it? All of you have drawn this network. Network diagram सबने बना लिया. I'm going to the next slide. Network diagram तो सब पहले बना लो. All of you एक network diagram. All of you have understood this. The purpose of this values, all of you understood? कोई बाकी है समझने के लिए? 4 6 8 क्या है? किसी को समझना है 4 क्या है, 3 क्या है? अभी बोल लो. It is now or never. Next we will go to another concept. Once you have understood this, नेटवर्क डायग्राम को अच्छे से समझ लो. एरो किस तरफ है समझो. नोड्स क्या है समझो. 3 टाइम एस्टिमेटर्स: मोस्ट ऑप्टिमिस्टिक टाइम, मोस्ट लाइकली टाइम, मोस्ट पेसिमिस्टिक टाइम. टाइम एस्टिमेटर समझ लो. कैलकुलेट करना है most expected time using the simple numerical method. Most optimistic time. তারপরে হচ্ছে most likely time. তারপরে হচ্ছে most pessimistic time. Optimistic time মানে ওটা minimum time লাগছে. মানে এই অ্যাক্টিভিটিটা করার জন্য suppose 1 2 3 is excavation. Excavation has started. Excavation will complete. Okay. So this activity from start to end, the least time which it will take to excavate is 6 days. The maximum time taking all the uncertainties it will take is 11. And there is 50% chance. Okay, the most likely time is almost you can say 50% chance that it will take 8 days to complete the work. Okay, these are the 3 time estimators. For every activity, these are the 3 time estimators. Okay, moving to the next slide. See how many paths you can see. Path A, suppose 1278. 1278. Path B, suppose 1 2 6 8 1 2 6 8 path C 1 3 6 8 1 3 6 8 path D 1 4 5 6 8 1 4 5 6 8 we are following the arrow we are going towards the arrow from the successor predecessor activity to the successor activity okay not against the arrow we are always going with the arrow forward with the arrow okay this 4 paths it is clear 4 paths you can see 4 paths here already completed 4 paths right now our what is asked in the question that how many paths in the question it is not good the question already has given the this network diagram so the question is asking that determine the expected time to for each the path we have to find out the path and you have to calculate for each path there will be most expected time how will you get for every activity you will get the expected time and this find the average you will get the most expected time for every path understood and from concept I will tell you so between A B C D path I have to find out which path is taking how much expected time from the equation okay next you have written this all you have written this 4 paths already written no doubt now no issue now for this path find out create this table find out the most expected time okay what you can do you can add up all the optimistic times okay from between 1 to path 2 7 path and 7 8 path you can add up all the initial optimistic times it is the summation of the all the optimistic times TO again for the most likely time the middle time of 1 to 7 and 7 8 do the summation of all the most likely time and for the most pessimistic time do the summation of 1 to 7 and 7 8 the last time is given okay what was the most pessimistic time for 1 to how much it is given in the network diagram most pessimistic time how much most it is 11 plus 2 7 2 7 11 plus 12 the what 23
35
that's 25 plus 7 8 7 8 plus 12 the what 35 is the pessimistic time भैया इस तरह से हर एक पार्ट का निकालो उसका this way you can do or otherwise जैसे मैंने यहाँ बोला for every activity you can find out the expression then you can just add up that will also do दोनों तरह से भी कर सकते हैं either you can create activity individual activity following the path just add up the these values you will get the ultimate or otherwise for every activity you can take individual optimistic time pessimistic time most likely time and pessimistic time and find out the most expected time understood try kore dekho both they can do see the calculation if it is correct or not if there is something wrong you can also just take it out check kar lo आते ना बोलते हाँ सब लोग को ही नेक्स्ट मुझे क्लास है टेबल हाँ optimistic time का कौन था first delta 6 is the optimistic for 1 to path 6 for 2 7 path 2 7 activity it is 8 6 plus 8 14 then 7 8 is your 5 what Then for every path give me the expected time. Follow the step. देखो तो पे करे. Now give me the expected time for every path. बोलो फर्स्ट बोलो. Like this way you can also do. For every path, individual activity you can take out the individual expected time and do the summation. Okay. Or you can do accordingly just like the previous step. Now see for path ABCD that is given, we were getting different values of estimated time, most expected time. Now which one will be the most critical time? Most critical time means the minimum time that it will take to complete all the works in the project, all the activities in the project. Okay. So now from the concept, now you tell me which one is the critical part.
1, 4, 5, 6, 7.
कौन सा वाला critical part होगा?
1, 4, 5, 6, 7.
Part A, B, C या D?
D.
Part D क्यों?
इसका टाइम लगता है.
It is taking maximum time. This activity is the expected time of this activity is maximum. To complete all the projects, it is taking the maximum time. So this one is the critical part. Part B, which comprises 1, 4, 4, 5, 5, 6, 7, 6, 8. This part is the most critical part. You can conclude from this table. Okay, but you have to do some reverse work. Yeah. Understood? Anybody who has not understood till now? With me? Okay? Okay, that's all for today. If you have any question, you can ask. On the next class, we will go to